as told before, one of the complicated things in order to do a generator Carnot cycle is the ability to perform isothermal heat transfer. So one of the ways to try to have isothermal heat transfer that are also isobaric, because heat exchangers are usually at constant pressure more or less, is to use the phase change from liquid to vapor from pure fluid or mixture that is behaving like a pure fluid. So here I will show how we can try to approach Carnot generator cycle by showing this cycle in a TS diagram inside the two-phase zone of a pure fluid. So first thing we can note are the temperature of the sources. So the Carnot cycle is defined by the temperature of the hot source and the temperature of the cold source, TC. And inside the two-phase zone, so here inside, under the saturation curve, these lines of constant temperatures corresponds also to isobaric lines, so lines of constant pressure. And so it is possible to plot also the lines of constant pressure that are merged with these isotemperature lines of the sources inside the two-phase zone. So this is for the high pressure, and this would be for the low pressure. So high pressure, low pressure. And so the Carnot cycle has two transformations at constant temperatures and two transformations at constant specific entropy. So because the specific entropy is corresponds to the x-axis, we can define two specific entropy. Low specific entropy here, that would be written as 1, and a high specific entropy level that will be written as 2. And it is possible to plot a Carnot generator cycle in such a diagram. So the Carnot generator cycle, so we can start somewhere, for example here. Then we have an increase of pressure and temperature at constant specific entropy to point B. Then an isothermal and reversible heat transfer from B to C at high temperature with a heat exchange with the hot source. Then an adiabatic reversible expansion from C to D at constant specific entropy, here the lower entropy level, and then finally the isothermal and reversible heat transfer with the cold source, so at the cold temperatures, temperature and cold pressure. And so this is the basic idea on which is developed the vapor compression refrigeration cycle. Unfortunately, it is not possible to do exactly a Carnot generator cycle, mostly due to technical constraints. It is not possible to do exactly the transformation that are proposed here. So the differences with the Carnot cycle will be developed